fifth.
I have a quick question.
Yes?
So if it asks to like say where it's concave,
So concave
if
up,
it's
we have to find the second derivative, and that has to be positive. Concave down, we have to find the second derivative, and that has to be negative.
yeah, does it ever have to go back up to have concavity?
No. So this is concave up or upward, and here is concave down or downward.
So for like an exponential function, if it just like sloped down for like infinity,
So for example, for the e
would
to
that
the
be
x,
concave up?
yes. So if you just want to graph e to the x, this is e to the x. It means that its second derivative is always positive, because it's always concave up.
Okay.
Is that better?
Yeah.
Okay, so now we're looking at 44. So 44, I'm assuming, is the function x plus 1 divided by x squared minus 2x minus 3. Is that the one?
Yes.
Okay, so this is, we can do it, of course, there is no question about it, but it's exactly the same with this one. Exactly the same. Was there some problem here with this?
Mainly just because of the vertical asymptote, and so that messed me up for most of it. Like, how do you find the vertical asymptote
Okay.
for those?
Very good. Okay, so let's do that. So we have x minus 3 and x plus 1. So far, so good, correct?
Yes.
So do not simplify before you state the domain. And you don't have to. Once you fill out the table, I'm fine. I can read the table. You don't have to say the domain is blah, 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 blah. You don't have to, because the table summarizes everything and I can see it. Once you put it in the table, I know what you mean. So obviously, not -1, not -1. Once you show me this, then I know that you stated that x plus 1 cannot be 0. 0 has to be in the table no matter what, and not 3. You don't have to say that the domain is all real numbers except -1 and 3. I see it here. Now we will simplify. Because I simplified x plus 1, I will write myself a note, whole. Because I cannot simplify x minus 3, I will write myself x equals 3 is a VA. The limit here and the limit here will follow. When x approaches infinity, I see what this is. It must be 0. Because it's 1 over infinity. Always remember, a pi divided by 10 billion. It's 0. So I write y equals 0 is a horizontal asymptote immediately. I plug in 0, I get -1/3. When I plug in 0, I get -1/3. You don't have to write f of 0 equals -1/3. There is no need. I see it in the table. Unless you want to. If this helps you and you have to have it, write it and then put it in the table. Then I need to find the limit from the left and the limit from the right. But for the whole, just plug in -1 here. Not here. Not here. In here. -1 minus 3 is -4. -1/4, -1/4. Yes, you can write the limit as x approaches -1 from the left of 1 over x minus 3. You plug it in, -1/4. But there is no need. If I see it here, I know what you did. Finally, I have to determine these limits. The limit from the left of 3 with 2.9. 2.9 minus 3, I know it has to be -infinity. On the right with 3.1, I know it has to be infinity. You can say, No, I want to see it. Fine. So then write the limit as x approaches 3 from the left of 1 over x minus 3. You know it's 1 over 0. 1 over 0 has only 3 options: infinity, negative infinity, or DNE, as we discussed in chapter 1. So 3 from the left is 2.9. 2.9 minus 3 is negative, and this is positive. Positive over negative is negative infinity. So this line can be filled in like in a blink. Now this requires more time because, you know, I have to differentiate and so on and so forth, but this is just the simplest rational function that we can come up with. Okay, so any questions so far on any of this? So now I exhausted the function. There is nothing else I can learn about the function from the function itself. X and y intercepts, if they exist, there is not, I cannot set this equal to 0. Whole, when x is 0, y is this, the y-intercept. Limits, because it's a vertical asymptote, and the horizontal asymptote. There's nothing else. So now I move on to the first derivative. So I'll differentiate. So I differentiate, this is my preference. You can use the quotient rule, but why? The numerator is a number. So then f prime of x will be negative 1, x minus 3 to negative 2. Always say times the inner function prime. Well, 1. But always say times the inner function prime at all times. So this turns out to be negative 1 over x minus 3, everything squared. I know already it's never 0. It cannot have any critical numbers. Furthermore, it's always negative because this is a positive number. 1 over positive is positive, minus in front, negative. No critical numbers, none, and always negative. I found something, I'll put in the table right away. Now, I have to check that these two rows work well together. This is when I catch my mistakes. If these two do not work well together, I'll say, oops. So let's check. From 0 to negative 1/4. Yes, that's correct. From negative 1/4 to negative 1/3. Yes, because this is negative 0.25 and this is negative 0.67. Yes. Yes. From here, here. Yes. From here, here. Yes. So this works well with what I have here. Now the second derivative, of course I'm going to differentiate this, not this. So then the second derivative will be 2 x minus 3 to, x minus 3 to negative 3 times the inner function prime, but it's 1. So I have 2 over, I don't like x cubed, I mean power 3, so I'm going to write it like this. Because I have to study the sign, and I don't want to study the sign of this. It's a waste of time. It's positive over positive. That's not going to change anything. This will change the sign. To the left of 3 is negative, to the right of 3 is positive. Or you just plug in numbers. So to the left of 3, negative. I will immediately put the sign in. To the right of 3, positive. I will immediately put the sign that the shape that I expect. That's it. Done. So now only this tells me the graph. So tells me what to graph, how to graph, everything. So first I have to graph the asymptotes. So I have negative 1, and I have y equals 0. This will be an overkill, so this is y equals 0. Then I plot the points. So negative 1, oh,
Negative 1.
yep, yep, yep. Not good. That's not what it says. It says whole. Good. So I have to let it dry for a second. So I'm going to start with this side from positive infinity to 0. No issues there. Then at 0 is negative 1/3. So if this is 1, negative 1/3 will be here. And then finally, negative 1, negative 1/4. Okay, so opening down, coming from 0, going through the hole, crossing the y-axis, going to negative infinity, all opening down, all decreasing. Done. So that's what we did, all those problems in class. So you have an example to follow, but you have to watch the video. It's not easy. If you don't watch the video, it's not easy to remember all those steps. So that's why I'm kindly begging you to redo the problems we do in class before you do anything. It will open up a new world to you. Okay? So just to make sure that that is a whole. I didn't show it as a whole. This is a whole. Okay? So it's at negative 1 comma negative 1/4. The calculator will not show that. So please don't rely on the calculator. The calculator sometimes lies to us. Quite a lot. Good. Naja, is this okay? And I also have to write the function that I graphed. What was the function? It was x plus 1 over x squared minus 2x minus 3. So now after you practice with these 3-4 problems, the table should be filled up in probably 3 or 4 minutes. Not the half an hour that I needed to explain the first example. Good. Other questions? Is there anything else you would like to ask? Naja, do you feel better about this?
Yeah, so much better.
Awesome.
Thank you.
Awesome. That's why I post those videos, just for your review, a quick review. You should not listen to everything, but just a little bit, so it gets you started. Good. Other questions for me? Is there anything else from anywhere else? Okay, so 2 things in 3.4. So we're going to try to accomplish today, I think I'm on page 3. So we're going to try to accomplish 3.4 and 3.5. So 2 different things. One thing that I would like to discuss here is max-min on a closed interval. So I want to choose a problem, or you can choose a problem. I'm opening the book. Where is my book? My book right here. Okay. So on page 314, if you can find it faster than I do, please do. Okay, I'm almost there. I'm sharing my screen. And where are you guys? I'm sharing my screen now. So no, I didn't want the calculator. I wanted the book. And I wanted chapter 3. I wanted 3.4. I'm going to move to 3.5 and then it gets closer, and then I can plug in, put in, okay, 3.5, and I want 3.14. So, or I just do this. Okay. So I would like us to choose a problem from here. Yes, these are okay, more sophisticated, and even these, but we can look at an exponential or a rational again or something else. So let's choose a simple situation, and then we can go for more sophisticated. So let's try, I don't know, 15. So in 15 on 314, we have f of x equals x to the third minus x to the fourth and negative 1, 1. So the problem here is asking us to find not just the relative and max and min, but also the absolute max and min. Okay, so let's see how we do this. So every time we analyze critical numbers, etc., we have to find the domain of the function. That's the first thing. But now we don't, because the domain is given to us. It's carved in stone. Done. I don't have to think about the domain. So I have f prime of x and f of x. Good. The domain is given to me. I'm not asked to find x and y intercepts. I'm not going to graph. I'm only asked to find max min on a closed interval. This is so-called closed interval. Closed interval. Good. So then I'll go ahead and find critical numbers. Find f prime as 3 x squared minus 4 x to the third. Although it looks complicated, it's really not, because I can factor out a negative x squared, arrange it in the correct order, descending order. You know me, I don't like anything that is not polynomials that are not presented in the descending order. So I factor negative x squared. I have 4x and then minus 3. Let's check. Negative x squared times 4x, here it is. Negative x squared times negative 3, here it is. Why did I factor? Because remember, critical numbers come from two sources. I always have to check both sources. Well, there is no need to check this one because this is a polynomial function. It's always defined. So critical numbers may come from here. And since it's degree, can anyone give us the degree of this polynomial? So we know how many solutions to look for. The degree